Happy Monday. How's it going, everybody?
It's going well. Happy Monday,
Good.
Joe.
Hey, happy Monday,
Welcome,
Matt.
Igor.
Igor.
Thank you. Happy Monday.
Yeah, TGIM. So it's awesome. Well, today on the Monday Morning Data Chat with Igor from Bigeye. For people who do not know who you are, do you want to give a quick intro?
Sure. So, hi everyone. I'm Egor Gryaznov. I am the co-founder and CTO here at Bigeye. Bigeye is a data observability company. We look at your data and we tell you when it looks anomalous or not fit for use. So then you can detect problems before your CEO or any important stakeholder does. I'm a software engineer that has been in data my whole career. Before Bigeye, I was at Uber. I was one of the first people called a data engineer and did everything from data infrastructure all the way up through ETL data modeling, reporting, and custom analytics applications there.
That's cool. Walk me through that. That's an interesting history because like Uber is, I think, world renowned for their data engineering, data science, data kind of everything. I know a lot of engineers that read their blog and so forth. But you were, one of the first data engineers. I mean, walk me through what was that like back then? What was being a data engineer at Uber like back in the like the 1890s or whatever it was?
The late 2014s. Yeah, it feels like it was 20 years ago at this point. So Uber is a really interesting culture. Something that's important to understand that a lot of people don't know about Uber is that it has everything gets built in house. Practically Uber doesn't really buy software. I mean, that was starting to change towards the tail end of my tenure there, and I think now it's probably a little bit different. But when I was starting, Uber didn't buy software. Our team brought in Looker, and there was a lot of pushback to just bringing in a reporting tool. And because of that, a lot of systems were built around you have to figure it out yourself. You have to fish for yourself. You have to answer your own questions. The tooling needs to be built in house, which was problematic in the beginning because that means the most data tooling we had was a text box where you could write a SQL query and then an export button to dump it into Excel. So then our ops teams can use that and do something with it. And that's, I may be exaggerating just slightly, but that is practically what we were dealing with. And my team was responsible for sitting on Slack. We used HipChat at the time, and we had a SQL channel, and ops teams would bring their SQL queries to us and say, I'm trying to get the following result, and I don't understand why this isn't giving me the result. And then the on-call data engineer would look at the query and then say, this is what's going on, and this is what you're doing wrong, or this table didn't load properly, run it again in 30 minutes. We're going to go restart the load. And so, but because of that, that also enabled the data team at Uber to build all of the stuff from ground up and have it be very well interconnected. So if you think about our ETL tool and our ingestion tool and our data modeling tools, they're all very tightly coupled. The lineage tool was then getting fed from the ETL and ingestion tool. Our data catalog called Databook was being fed from all of this upstream systems as well, because the teams sat next to each other. So the PM for one team, the engineers on one team can go and say, this API doesn't work for me. Can you add this other information, or can you change it in this way? And someone will say, yeah, cool, sure, why not? Let me go do that right now. And that built this great ecosystem of tools that are well connected, well designed, and they allow for workflows kind of across the whole data landscape. And that is why Uber engineering, especially on the data side, was so compelling and so interesting, is because all of these things were created from first principles in a way that would make it work. Now, I'm going to take a step back and say why that's not great. One, not everybody has a 150-person data team. Like, that just doesn't happen at most organizations. So obviously this isn't a scalable practice. Second, there are a lot of things that you do not have to reinvent the wheel on. I have my own opinions about what is reinventing the wheel and what isn't, but a lot of things are reinventing the wheel. ETL tools do not need to be reinvented for the most part. Third is, because all of the tools were so custom and so well fitted together, ripping out a tool as is out of the Uber stack and then putting it in another team stack probably just wouldn't work. Or it would require so much customization that at that point you might as well just rebuild it from scratch. And so a lot of what we are doing at Bigeye is sort of we took what we learned there and we said, okay, well then how does this extend and generalize? How can we make this work for every stack and not just for the stack that we were familiar with?
So loose coupling, basically, and presumably a lot of standard cloud services integration so that you can just talk to all kinds of tools that people are already using.
Exactly. And like, for example, Snowflake was not really a thing when we were getting started. We used Vertica at Uber for a long time as the data warehouse. The Hadoop team came about. A lot of the large compute workloads went to Hive, and then we synced the results into Vertica. And then Presto came about, and everyone used Presto for analytics at that point. And by now, I think I know it has completely superseded Vertica internally. But if you're looking at teams today, they're going to go out and they're going to say, I'm going to use BigQuery or Snowflake. Maybe Redshift, but much, much rarer now.
Yes.
Yes.
That's interesting. What are your thoughts on reinventing the wheel? When are you reinventing a wheel, and when are you not reinventing a wheel?
So there are core concepts that every data team is going to need to represent. I mean, transforming data is one of them. And there are so many tools out there right now from, all right, let's take data, transform it into something more usable, and write that data back out. And that's classic ETL. And I mean, I don't really care about is the ETL between two systems within a single system. I'm not going to worry about that part for a second. But for example, dbt is great. We internally at Uber had something that looked similar to dbt, where you wrote some configs and you had some templated SQL files and they would run, and that's how our core data modeling team operated. There have been drag and drop ETL tools where they said, okay, cool, apply this transformation, then this one, and then write it out. And across all of these tools, the concepts are the same. And I feel like reinventing another process for doing that is sort of starting to reinvent the wheel. The thing that I would be more interested in seeing in the ETL space is, how do you extract building blocks better? All right. So how do I say, okay, this is going to be a repeated transformation. How do I make it a canonical transformation that I can reuse across multiple models? I still have a hard time today doing that. Like, I can't just say, this is how I apply a function, take two columns and output a third one, which is the result of that transformation. Now, when I was working on experimentation analytics at Uber, so it's A/B test analytics, we rewrote everything in Spark, even though Spark was fairly new. This was like before 2.0, even, I think. I think we were on 1.4, 1.5, whatever it was before then. And the reason I did that is because we rewrote all of our transformation as Java code, as small functions, and then we just applied functions to data frames. The ETL logic was literally to pull down the data, apply a bunch of Java functions, output the result set. And it was more of a pain to manage, but it ended up being a lot more composable. And whenever we needed to say, okay, I need to transform the experiment ID into an experiment name, great, here's my function. I don't have to reinvent the wheel, rewrite it in SQL, and I update it in one place only. And that's the sort of like things I would like to see coming out of these tools, rather than saying, here is a different way to do the same process.
See, Chris Tab. Hey, good morning, Chris. He's in New York right now. Yeah, he says, I agree. A company should promote reusable data assets. I think this is something that Matt and I would violently agree with as well. Because I think it's interesting. I mean, we're talking about reusability. I think in different ways. For the longest time, it was maybe reusing pipelines or infrastructure as code and stuff. But I think I'm starting to see this more and more. I'm seeing companies that are coming out with sort of maybe prepackaged transformations, even just as simple like a fact table or if you're in the data vault world, like prepackaged at least starter kits for like satellites, hubs, links, or whatever, right? And so I think this is pretty cool because the amount of I would say just kind of reuse, or not reuse, but reinventing the wheel in that area seems to be like a very cold start problem for almost every single data team. Like you want to make a star schema, cool. You basically have to start from zero and do that every single time. So
DBT has taken a big step towards that. They have a reusable repo. For example, I think I've seen the Fivetran and HubSpot ones, not Fivetran, the HubSpot and I forget the other name, but it's pretty much, you are ingesting HubSpot data through Fivetran. Great. Here is a drag and drop way of you to say, here's a starter star schema for your HubSpot data.
That's cool.
And I think that's the right way to go. But I think there's one level of granularity down from that. Even within a single organization, there's going to be logic that you need to apply all the time.
For sure. Yeah.
And that, like, a great example at Uber, there are, at some point, regions got renamed. So I think it was like Southeast Asia and India got split up into Southeast Asia and then a second region for India, which means that all of these mappings in the hundreds and hundreds of tables now had to be updated simultaneously. Otherwise, all the reporting would break. And so ideally, that there should be one place that says, tell me the city ID to region name mapping. That should just be a function. That function should be updated by some central governance team or even the subject matter experts within the organization and say, this is how finance maps cities to regions. Everyone should be using this. And if you're not using this, then it's your problem and not ours anymore. But because of the decentralization of logic in ETL frameworks, this now becomes everybody's problem. And that's impossible to scale.
That's interesting. I know we spoke about this a few weeks ago, a month ago, I can't remember. The notion of the data mesh, right? I mean, so you're talking decentralization, centralization. What you just described, data mesh would seem like an absolute nightmare in that scenario.
Yes.
Good answer.
Yes. It's very direct.
Yes. In this scenario, a data mesh would be an absolute nightmare. Data mesh, I think, is great if you had this sort of logic isolation, and then each individual team in the mesh could define the canonical function for this logic. So let's say you had the finance data team, and the finance data team says, we own region mappings and we own conversion rate, like currency conversion rates, and we own maybe something else, like what is considered a like profit versus, like what is the formula for profit if you feed in all the trip financials. Great. So they maintain those three functions, but they should be able to export them back out to everyone else to say, all right, if ops team in New York, you want to go figure out your city's P&L, or you want to figure out your city, like how much money you made, or Europe, you want to figure out in dollars how much money you're making, you can do it here. And it's easy because we are going to stand by our formula and we will keep it up to date. And anytime currency conversion rates change, we're going to update the underlying logic and you don't have to worry about it. So I think in that sense, data mesh could actually solve the problem better. The problem is there's no way to push that knowledge back out to the rest of the team. And this is why hub and spoke models are so popular, because then you say all of the hub takes care of all the like things that need to be common, and then the spokes just help implement all of that.
Yeah, and more broadly, you have this notion of a metrics layer, which I think, what would you say, Joe? I think DBT is kind of doing that with like these standardized templates in Fivetran.
I mean, they claim to be recreating a semantic layer, a metrics layer as well. I mean, I think this is the buzzword du jour that kind of also reminds me of Sasquatch in a way. Like I hear a lot about it and I don't see it implemented. I think the first time I actually saw a true semantic layer was LookML, but that that's. But I think there's a lot of things coming. But anyway, continue with your point, Matt.
Oh, just basically that. I mean, I think this is We've had Bill Inman on the show, and I think at first he kind of came off as anti-data mesh, but really his point was, okay, you can have a data mesh, but you probably also need some kind of central team that generates standardized reporting off of the different data domains. It says, all right, we as a company are going to have some standardized reports. We, as the central team, are not going to own everything. But we are going to take the data from the different teams and standardize it somehow so that people are getting a consistent picture of KPIs without having to run their own queries against data that might be changing behind.
Well, in the data mesh, that's the underlying federated layer, right? Where it's, at least there's some governance or consistency across things. Because without that, you'd just have like complete anarchy. It would be, yeah. It reminds me of like what banks were like maybe in the 1800s, where like every town had a bank and
its own money.
Yeah, and its own money, and it would just like have fun with that. So, yeah. But then it gets more, I guess, fractal in a way too when you start considering data sharing and the consequences of that across companies and across organizations, and intra-company data sharing and intercompany data sharing and so forth. Anyway, it's something I was thinking about this weekend because I live a very exciting life. So
that's why we're here. That's why we're in this space, right?
Yeah, Monday morning data chat's more of a chance to like vent.
Here's what I was thinking about this weekend.
Childhood data trauma, basically.
Yeah. Basically, yeah. So, that's interesting.
Yeah, I think without having that central layer, it's very difficult to get any. I mean, even the data sharing, it's like what can be shared and what can't. That should probably live in a more centralized layer, in that federated layer, because they should have a canonical say on, no, we cannot share emails. I don't care if like 3 teams are have emails in their tables. We cannot be showing that in a report, for example.
Mm-hmm. Interesting. So where does like data reliability and data observability fit into centralization?
So that's a great question. The way that I see it is that data reliability is the concept of, do you know whether your data is fit for use, right? And so there are going to be tools and processes that you need to implement in order to have and ensure data reliability. And a lot of the tools and processes should be owned by a more centralized team, because they should be extensible and reusable, and like a lot of things can be centralized there. Whereas, for example, we use like we as an organization want to use Bigeye, or in the ETL use case, we want to use DBT. All right, now team A, you're responsible for this schema. Here's how you can use Bigeye. Here's how it's going to help you. Here's how you would use DBT. Here's how you build your models and publish them. The central team can provide that support and that standardization, and then the other teams can then go and help actually populate the information into the tooling and follow the processes. So from a data reliability perspective, it's, if I'm the finance team and I need to tell you that the finance data is good, what does that mean? Well, prices can't be negative unless there's unless it's a refund, or the like IDs need to be populated, and if a order is completed, then it has to have like a valid like shipment ID or something like that, right? And then the finance team can then say, let's encode all of these rules into the tooling, and then if all of these are passing, finance data is good. If your report's bad and you come here and you say, nope, the finance data is passing all of its logical checks, then great, you're going to move on to the next step, which is, okay, are the tables updating on time? Is there like something else? And sure, sometimes those bleed over a little bit, but that's how I could see data reliability getting implemented across something closer to a data mesh or a hub and spoke model. And that's what a lot of our customers are doing too.
And so are we talking about basically data contracts in some sense here?
Yeah. We call them SLAs. We're trying to follow as hence data reliability engineering, kind of like a DRE to SRE is what data SLAs are to engineering SLAs, which is you have a bunch of rules that you're tracking about your data. In engineering land, that would be uptime. In data land, that's how often is your data matching your expectations of it. And the subject matter experts, the business domain experts are the ones who know the expectations and need to be able to encode them. But there's a lot of, you still need to track those over time and need to know when they're being violated. You need to have a way to surface that to the end user. So if I'm on a dashboard, how do I know that this dashboard is affected by a violation in this SLA. And so chaining all of that together is the tricky part of the tool.
How do you deal with SLA violations?
You have an owner, and each owner needs to respond appropriately. I think it's the same thing for engineering. No two software pieces of software are going to have exactly the same response pattern for an SLA violation, in the same way that no two data sets are going to have the same response pattern. Let's say I said, let's say you have an SLA around timeliness, right, of your data. Is my report updating on time? Which means, are all my components that are feeding into the report, are all those tables updating on time? Now, two different reports might be being fed from two different sources. And one thing might be, the DBT job didn't run, let me restart the DBT job. The other one might be, our third-party data provider didn't upload a CSV file to the SFTP, let me file a ticket with them. And that is a very different response pattern that needs to be documented, but it's up to every team, and it's up to every individual SLA violation around what you do with it.
I got a question here from Paulo. I'm gonna ask him to clarify the first part, but or the second part. I asked him to clarify the first part. What would be the advice if we get problems related to accuracy, precision at data sources?
Yeah. So tracking them, I think, accuracy or precision is a broad term. So Paulo, if you could clarify what you mean by accuracy or precision, just give a general example is enough. But the way that I would interpret accuracy is, does the content of the data actually match what you expect? And so, for example, let's say you're looking at a price column in your orders table, and you're like, okay, well, you as a data engineer might not know what the distribution of the price column needs to be, but you know that historically it was between, let's say, 1 and 100, and now you're seeing a value that's 1,000. Now, that's weird, but as a data engineer, you don't know, should I drop that 1,000 value because it's anomalous? Is it a real, truly a black swan event in the business? This is when you need to take that and take it to the finance team and say, who needs to answer this question? And then once you find out who is answering that question, you can at least make them responsible for that sort of violation in the SLA. That said, there's a lot of things that you as a data engineer should be tracking about your data reliability story, such as update times, freshness, completeness, how many rows are inserted, and is that expected? Nulls, like, are we dropping columns on accident? These are things that you actually have more control over, because you control the pipelines. You could easily typo, forget to schedule a ETL job, forget to turn it back on after you paused it. There's a lot of things that are within your control, but if it's in your control, then you're responsible for it. And if you're not, then you need to find the person responsible for it. Data reliability it's a team effort. You can't just force the data engineering team to do it all themselves. You're sort of the steward of data reliability at that point, and you have to find the people that need to be involved in the process. And in the story, you can help show them the process for how can you find out that it's a problem, and what next steps do you have. But someone else might be responsible for taking those next steps.
And as a follow-up, he writes, what I mean is, normally we collect data from different sources, and actually if we get variation from those observations, we practically can do nothing about this kind of thing, right?
Yes. Broadly, yes. And I think this is where it depends on how you're going to define your SLAs. Because you can have variation. Let's say, here's a good example, row counts. Let's say you are receiving server logs from some third-party source, right? I'm making up a contrived example just to prove a point, but let's say your service provider is saying, I'm going to dump all of your order logs. I'm going to dump all of your order logs into this S3 bucket, and you're going to go pull them and ingest them into your warehouse. Now, maybe on a given day, you have anywhere between 5,000 to 7,000 orders. And that's a reasonable range. And a variation from that might be, I received a file with 1 row in it. That sounds really bad. And at least what you can do about that is just ask the provider, is this what we expect? Do we actually have 1 order? Because that seems wrong. Now, if it's 6,000, and that's still in the 5 to 7,000 range, and this is what data observability tools try to help you do, is find that range for you so that you don't have to manually inspect every single piece of data and every single property of that data to find these variations. But some variations you do have control over, but others, yes, you do not. Like we talked about with the actual domain expertise where it's necessary.
Christoph has a statement / question. First says inline checks are easy. Follows up with the question that how do you manage data degradation?
Yes. One of our favorite topics. So data degradation is interesting, and I'm going to interpret the data degradation a certain way. And Chris, feel free to let me know if I'm not interpreting it in the right way. So data can change slowly over time. So for example, let's say you have a column that is around 1% null. Let's say it's a phone number and not all your users enter a phone number, but the vast majority of them do, because they let's say 1% of users signed up from the web and they don't require a phone number. And then let's say that number just starts climbing, and your 1% null a month ago turned into a 2% null today, and then maybe in a week from now it's 2.5%. That's a slow degradation, and a lot of times it's really hard to catch that. So something that we're working right now that we've started implementing at Bigeye is detection for pattern changes. So in this case, it's not enough to just have a tolerance range, because the tolerance range, any machine learning, any anomaly detection algorithm would probably adapt if the degradation is slow enough. So for example, if it went from 1 to 2% to 2.5%, and it just kind of slowly climbs, standard deviation, interquartile ranges, even a lot of machine learning models will slowly start just adapting to it, because they'll realize, oh, that's just what the data looks like.
Yep.
Or they'll start expanding. Now, pattern changes are great to detect data degradation, because you can say, it used to be flat. It used to be pretty much flat, and that looks like a flat pattern, and all of a sudden it started climbing, and now that's an increasing pattern. Or maybe it was flat, and now it's a decreasing pattern. Or it was increasing, then decreasing. Once you get that inflection point, you can say this was a pattern change. And that may or may not be an issue, but you can at least flag that to a user. And this is where thinking about data problems, it's not always, is this within a certain tolerance range? It's really is like, does this behave as I expect it to behave? I expect my data to be fairly consistent. And so if it's changes, the pattern of the data changes, you would want to know about that.
Interesting. How many of these techniques that you're looking at, I mean, because it seems like a lot of time series analysis.
Yep.
At the end of the day, are you guys having to kind of dig into the archives of time series techniques to figure out new ways of approaching this? Because the data stuff, as you mentioned, a lot of that seems pretty sneaky. I have a background in forecasting, so I'm pretty familiar with a lot of these techniques. And the thing with these techniques is they work until they don't, right? So I think what you ran against is like the approaches that you took are great, except when you see somewhat of a phase change occurring before your very eyes, and you're like, well, is this an anomaly, or is this new? They're not the same thing. So.
Well, just as you mentioned, like 2014 seems like ancient history. The economy has changed. The web has changed dramatically. And it's the same classic alerting monitoring problem that you have in DevOps, which is you don't want to under alert. You don't want to over alert, because if you over alert on Slack, then people just get fatigued and they start ignoring things.
Yeah. Now that I realize I'm talking to an expert, I really hope I'm not misrepresenting what my data science team does, because that would be really not great. But
they're all doing it wrong. No, I'm fine.
Our data scientists are watching this. They're like, "What are you talking about, Igor?" I'm about to get a talking to after this. I'm just kidding. It is a lot of time series analysis. It is a lot of luck. I mean, lucky for us, the time series forecasting and analysis and outlier detection, anomaly detection, these fields and statistics have been around for very long, and there is a lot of prior art to pull from. And the interesting question is, what what techniques do we want to compose and combine together in order to show that holistic picture? Because a lot of like early anomaly detection stuff when forecasting was when Facebook came out with Profit, it was plug in Profit and use Profit. And then you kind of like dust off your hands and like, ta-da, forecasting. And spoiler alert, it doesn't work that way. And so for us, the journey has really been figuring out what techniques need to be combined in what ways in order to get a meaningful result for the audience that we intended to.
For sure. Yeah, and the thing is, every data set's different too. And so this is, where the it's so kind of back to the inventing the wheel, reinventing the wheel sort of thing. In some cases, there's like a general topology, which is probably works for as a tool, probably works for like everybody. But then there's specific stuff with respect to a time series where it's like that's where it starts getting I imagine to a pretty hard problem, because every data set's different. Therefore, different techniques are going to have to be applied depending on the data set and depending whatever you find in the data set, because it's not like everybody has the same data. So if you did, you'd have the same business, in which case that'd be kind of cool too.
Yeah. One of the most interesting things has been in our in our internal dog fooding environment, for a very long time we had either contrived examples. So we know that this job will generate exactly this many records every single hour, and it's going to insert into this table, and they're going to get transformed every 4 hours into this roll-up table. And we tried to simulate an environment. Then from there, we progressed into Snowflake Marketplace and like public data sets available on there, and just pull down as much as we can. Sadly, not all of them are super interesting. One of them is really interesting, which is I am in California. California publishes its COVID data daily. So that's actually, for a while, they actually had to stop. They stopped publishing it, and we caught that, and we're like, oh, interesting. California stopped publishing COVID data.
Interesting.
Then they started it back up again. But that was an interesting example, because that was a good measure of is our system performing well? Because if you go on the news and you're like, there is a surge, we're like, okay, does Bigeye say there is a surge based on the data that California publishes? And yes, it's like, oh, your average has started trending up, your max value over the last 7 days is jumping. Like, it's just everything kind of starts trending in one direction. But that still was too regular and too constant, because now what we're doing is we're building a full-blown system around what are different patterns that we could expect to have, and which patterns do we not perform well on, because now we also have that corpus of knowledge, and building this giant backtesting framework of we can set a baseline for ourselves, and we can just get better against that baseline. And maybe at some point in the future, we'll even open source the baseline in our results and say, let's have a little forecasting competition. But
oh, that'd be fun.
Distant future.
Maybe you could supplant the what is it, the M3? I think it's the classic forecasting comp they still have. So that's really interesting. I mean, another data set you should look at is for COVID is Utah, because they stopped providing public testing several months ago. And so that would have been interesting to look at, because it's basically like, oh, if you're not testing for COVID, then I guess there isn't any. So it's all good. So what are some other interesting data sets that you found?
I know we talked about this right before the show. I am a big finance nerd. My half joking dream is Bigeye the hedge fund, which is we just get really, really good at time series forecasting, and we just run that on the public markets, and we call that a day. Same as what we talked about earlier. There's a lot of money and resources and talent being dedicated to let's trade programmatically. So there's no way that is ever a viable business model. But market data is really interesting, because it is extremely consistent. The markets are open, and when they are open, there will be every 5 minutes you will get a tick mark for those all those trades for each ticker. And the interesting thing is the data acts completely purely based on externalities. There's nothing about the time series itself that will tell you that the time series is going to move. The only thing that tells you that the time series is going to move is the externality of someone is buying or selling stock, or there's a big news event that you still can't infer from the time series. And so I think this is why forecasting for financial data is so hard. And I actually that is really the sort of the mecca of forecasting, right? It's like if you can build something that's generalizable and applicable for every single ticker in the public market, you are doing a great job. Even if you do it hit 80% on the mark, you're still doing a great job. And I think that's, if we got into any data sets, scraping that would be very interesting in playing around with it. But also, I'm not positive that fits into data reliability. That's more like pure forecasting off a numeric time series. Data reliability, it's like the value will never be null because we know we will have a record. We know it will always be on time. And sure, maybe you can detect some weird data delays in your NASDAQ feed, but that's not super interesting from a data reliability perspective.
Kind of bring it back to data reliability and data ops as well. Like one aspect of DevOps is incident response. So it's like you learn about an incident. What are you going to do about it? What are some practices you've seen that work really well with finding out about data problems and correcting them?
Yeah, we talked about SLAs. SLAs are definitely a great way of finding out about it. If a SLA is violated, that should alert a channel in Slack, an email address, a team. Someone should know about the fact that it alerted. Then from there, you get into, great, now what do I do about it? And this is where you can borrow the same runbooks that SREs have of, if this alert has fired, follow these steps. So we internally at Bigeye have runbooks for our on-call, which says if you're getting paged for X, go to this section in the runbook, follow these steps. And the steps are usually like one, like log into this part of AWS, check for these logs, look into Datadog, see if like our error rates increased for this endpoint, because that's usually what happens. If that's true, then go spin up more instances of this worker. Or for example, maybe the servers, the database is in a bad state, go like kill the bad query or something like that. So there are always like debug focused steps, and then there's resolution focused steps. And I think the most powerful thing you can do is streamline as much of the debug steps as possible. So take all that information and try to shove it into one place right when you get the alert. So if you get a data alert and it says, hey, this table is stale, it's delayed. It usually updates every 4 hours. Now it's been 6 hours and it still hasn't updated. Okay, great. And then when you click on that, that should say, oh, and it has 2 upstream tables. One of them is being updated on time. The other one is stale. And you're like, oh, great, cool. It's because of that one. Now, can I like walk that further back? And then the final step is, well, okay, what do I do about this? And that's where I think the ideal end state that I'd want to get to is I push a button and Bigeye just does the job for me. I push the button and Bigeye says, okay, you are resolving this problem because you've encoded this runbook already. We know that it means rerun the upstream job, then rerun your job. And let's try that. And we're going to try that first. And then if that doesn't work, we're going to throw another error back at you and make you go do something manual. And so I am always wary about performing operations, especially potentially destructive operations in a user's environment. That's just terrifying to me as a business owner. But I think that's the sort of end state, is encode your runbook into this tool and have the tool do as much work for you as possible. Probably starting with that surfacing information and then going into doing the actual operations.
How do we deal with incident response for external data sources? So increasingly with clients, we'll often see that they have maybe 100 SaaS platforms that they're pulling external data from. Any of those can have an incident. Any of those can have a data problem. How does that affect like the incident response conversation?
Each of those data sources probably has owners, and you have to just delegate to the owners. I think it really is, when I was a data engineer at Uber, the biggest pain point for us was, I mean, I'm going to be crude here, but shit rolls downhill. Anything that is a data problem fell on the data engineering team. And it was like, this is up to you to fix it now because there was a problem with the results of my query. Now, it doesn't matter that that came from an upstream data source, that our processing was delayed, that the query errored out, or there was or the user put a limit 100 and they didn't pull the full data. Like, that's not the user's problem. Is all of a sudden that is the data engineering team's problem. And it's something that I really want to encourage is having a healthy balance of who should be responsible for what problem. The data engineering team, really, they are responsible for the pipelines are up and they're flowing and they're running on time and we're not truncating data sets on accident and we're loading upserting things correctly and the frameworks are working, everything is operational there. And so things like freshness, nulls, row counts, sure, data engineering teams probably can do something about that, and it's probably within their purview. But there's a lot of data problems that are outside of the data engineering team's purview that are more suited for the subject matter experts, for the domain experts, for the, hey, guess what? Maybe this city stopped reporting for a while. Maybe our website was down, or we made a change to the data we're publishing, and we don't publish this field anymore. Not the data team's problem anymore. This is our. We need to just update our SLA and say that this field doesn't exist anymore. So the goal is to delegate the response to the true owner of the data, to the person that can do something about that. And that's really what I would like to see the data world get to.
Yeah, it makes sense. I mean, just detecting the problem early makes such a huge difference from what I've seen. I mean, often have we seen this, Joe, where a data problem is there for like a month and people are just
longer
running
than that.
bad reports.
Yeah, sometimes you might have a data problem persisting for years and nobody knows about it.
Yeah.
Right. So I mean, this happens, I would say, not too infrequently. But again, as we always kind of I think it's almost cliche now, but we always, when we start hearing things like, at least it's directionally correct, right? Like the report or something. Like, it is what it is at that point. I don't know. But what's interesting, if you kind of bring it back to the COVID data example, right? So if you didn't know, for example, that testing had changed in certain areas, you would just say, oh well, it looks like it's all gone, right? Or there's nothing more to worry about with respect to COVID in this area, right? Well, maybe it's just because underlying the data set, you just stopped testing everybody, or people got at-home tests or whatever. So I think having that subject matter expert who really does understand the data set and is on top of it, I think is paramount. Because otherwise, if you just blindly threw, say, that data set to a forecasting model that you're relying on, you would be very screwed. So.
Yeah, any sophisticated machine learning model becomes just complete nonsense if you can't rely on your year-over-year comparisons and you're trying to make a year-over-year forecast.
Yeah.
It's because a lot of forecasting came from financial forecasting. That's where most of these models and algorithms came from, and that financial forecasting typically has seasonality, and they typically have reasonable patterns that you would expect. Like, things don't just drop off a cliff at a certain point in time, and they don't have unknown like spikes and jumps and whatever it is. But modern data sets just aren't like anything that's not a financial data set isn't like that. There isn't always seasonality. There isn't always low variance between data points. Like, sometimes there are some data sets that are just like this 24/7. You just can't do the same sort of modeling there.
Well, the other interesting thing is too, I think people, unless you're really aware of how this works, it's very tricky. So there's a notion of top down and then bottom up forecasting, and these two don't ever reconcile. So if you try and take things at a granular level and then total them up, your forecast, that's never going to match what you have from a top down aggregation where you're trying to potentially allocate down or whatever. And so, but I think a lot of people blindly assume, oh yeah, I mean, if we just, everything's the sum of its parts, we'll do this. But if you get such noise at a very granular level where you might have only 2 data points, and you're trying to forecast it out for for whatever time period, it just doesn't really work that way.
Which always is interesting, because then there's the every finance team has their like margin of error where they're like, if I sum up all of my parts and it's within $1 million, we call it a day, and we're like, yep, close enough, like that, good enough for us. And the bigger the company, the larger the margin of error, and sometimes from a pure like thinking about the absolute value of that error is astonishing to me.
Mm-hmm. Oh yeah, and it's crazy too because you're making a lot of assumptions on I just think an inherently wrong basis, but that's probably a story for another day. Actually, we want to get back to a question that Chris Tab asked. Chris is just full of great questions. So he asked, are you focused on costs of pipelines, aka FinOps, or are you more focused on lineage and quality?
So Bigeye today is focused more lineage and quality, data reliability, fundamentals, getting the teams aligned, setting up their SLAs, knowing what they're monitoring and why and how. The cost of pipelines is an interesting one because that's, if you get really, really abstract, you can apply observability concepts to practically anything, right? If we, it's going back to the same thing we were talking about just now, Joe, which is, yeah, forecasting is forecasting is forecasting. Like, at the end of the day, it's a time series, and you're trying to find a pattern and detect an outlier, an anomaly, and a trend. And the for cost of pipelines, I think that is very top of mind for people. So I could see applying the same techniques to cost of pipelines. We actually, interestingly enough, had a customer who used Bigeye in order to look at their spend in Snowflake across different warehouses and try to detect if a given warehouse in Snowflake was all of a sudden using more credits than they expected it to. Which the data is available in Snowflake, so yes, they could do that in Bigeye, and it's not quite what Bigeye was built for, but that was the use case for them for observability, and it's definitely started kind of blurring those lines. And the lines get even more blurred if you think about, okay, if I'm doing if I detected an anomaly in the sum of all sales by region, right? Is that really data reliability, or is that more of a business anomaly? And that's where like the lines start getting really blurred in some of these cases, but it's all possible. And I think the costing thing is we're going to see that more and more, I would guess.
Well, another place where it's entangled is, say your site gets attacked by a lot of bots. You're going to see some big changes in your data potentially. And also it might drive a big spike in spending in parallel. Like you have to process 3 times as much data. Snowflake costs way more than you would expect it to. I'm a bit curious about this at Uber. To what extent were you guys relying on like ephemeral, scalable infrastructure where FinOps would be an issue, or were you more dealing with static infrastructure of some sort?
Vertica was all static. I mean,
Okay.
if for those of you who have never worked with Vertica, I'll give you a quick rundown. You have a bunch of physical boxes in a data center, and they have to be networked just right so that they don't blow up your whole data center network. And then you, if you want to expand the cluster, you add more hardware. The nice thing is it scales pretty well and definitely sublinearly. So we were running multiple 32 node clusters, and that was good for us. Like that worked out and that scaled enough. The effect, once we got into Hadoop and we just had HDFS and everything was just running on, like, dump everything into our HDFS file system and then process it later. That's when we got into chargebacks. And that's where it's like, okay, how much is each team storing? Each team had Kafka the Kafka team had the same problem, which is which topics belong to which teams and how much of the Kafka workload is being used to serve those teams. And then there were some really hard discussions around. I mean, on the experimentation team, we had the second largest topic by bytes in Kafka, after the sensing and perception team, which is the like, where is your phone? Like, is it moving? What is it doing? Because we logged every experiment for every user anytime they entered it, changed a treatment group or anything, and there were a lot of experiments and a lot of users, and they logged into the app a lot. And so that was, and we had to go through the discussion of like, how much of this do we care about and how do we reduce our log volume? Because you just get shown a number and the number is very large, and they tell you this is what it costs to process and store your data. You guys got to do something about this.
Oh wow.
So it's you do get into chargebacks. We had a dashboard for each team. Each team knew how much they were spending, how much infrastructure was spending about in order to maintain their data. So
interesting. Just got a question here, and for the audience, probably got time for one more question after this one. This is from Lenore. She asks, well, she first says, I totally agree with Egor on data changing over time. The SMEs are going to know best what data to capture, and these may change over time as they learn new things. She asks, what systems and or human relationships have you seen work best to ensure these changes both conform to the agreed upon lexicons and the data pipelines are ready to consume those changes?
Talk to your data engineers. I mean, you go make sure that there's an open line of communication between the business and the SMEs and the data engineering team. I think the biggest problem is when there is no face-to-face open communication about something is going to happen, and it all goes through docs and through these like tickets, and like the finance team files a ticket and says, pretty much gives a fact in that ticket, which is in 7 days, we will change this information about our data. And we really hope the pipelines adapt by then, otherwise the dashboard breaks. And then that ticket kind of falls into a black hole and doesn't get seen for 7 days. And then on day 8, all of their dashboards broke, and they say, data team, why didn't you make this change? And they're like, well, we didn't know what was happening. And this, having an open line of communication, talking to people, having that process, a good process that I have found is making sure that anytime there's a major change, like I'm adding a column, I'm dropping a column, I'm creating a new data set, I have a new expectation, you go in and you literally just send an email, send a Slack message, like try to get in front of the team. And if you're a team that makes changes a lot, then maybe have a recurring 15-minute sync every week and say, this is what we're doing with the data this week. FYI, is this going to cause any problems? And eventually you will find the right process. And I think it really depends on the cadence of the change and how often things are moving and how flexible your platforms are and how self-service they are. But having the touch points with your data engineering team is going to be very important in order to do this. And you can also then canonize it in a data catalog, and you can have documentation around it. The problem is that cannot be the only way you communicate. Just going and updating a data catalog entry and then saying, well, I'm going to assume everyone knows this now, is not the right answer. You just have to kind of talk to the people. And same thing goes, and the same thing vice versa. If you're a data engineer, talk to your business stakeholders. So if you are going to make a major framework change, tell them that this is what's going to change. We're going to change how we're doing incremental processing. Does this work for you? And if it doesn't, let's talk. Let's have a conversation about how you're doing your processing and why this won't work. So there needs to be that open line of communication. There needs to be more outreach. And I just worry that the data teams are sometimes way too siloed, and they sort of operate in this bubble where everything comes through inbound requests rather than an open line of communication.
Oh, Joe, you're muted. I think.
I know that. Yes, of course. I love the sound of my own voice. So I remember the other companies I worked at where, and I tried to put the onus back. So if you're going to make a change, don't just passively aggressive send me an email and tell me about it. Own the change. Come talk to me about it. Make sure I'm aware of the ramifications of this. Because what would really irritate me was, you talk to another department and said, "Oh, I sent an email about that." It's like, look, you know how many emails I get each day? Come talk to me. It's the lowest fidelity thing. Don't come to me after the fact. And then, because then it becomes a bit of a cop out. Like, oh, I sent the ticket to you. Did you get the ticket? If you're going to make a change, own that work, and owning it means communicating with stakeholders and making sure that they're aware, on board of everything. I completely empathize, having been there. I absolutely hate it when people do that. I've been known to yell at people for doing this. So
I also mentioned the hub and spoke model for data engineering. This is where it would be extremely useful to do this, is if you have a central data engineering hub that says this is all of the framework and process changes that we implement, they can then communicate out to stakeholder teams through the spoke, through the embedded engineers in this directly in those teams. And that eventually you will have a large enough organization where you pretty much need to do something like that.
Right.
And like having one central team sit down with every stakeholder team just becomes untenable.
Well, it feels like increasingly we're seeing embedded analytics. That is where the data engineers, instead of just pushing data to internal stakeholders and business users, are pushing it back to the application. And I think Uber is a classic example of that. And ideally, that drives this notion that we, as the engineers working on this application, are stakeholders in analytics. And so we need to inform the analytics team when things change so our dashboards don't break. Not just business's problem over across the wall, but like the things that our users are going to see day to day.
Interesting. Well, cool. Anything else in your mind you've been thinking about recently, or?
Yeah, looks like Dennis had a question, which is
Yeah.
going to.
Let's get to this one. That's actually from YouTube here. Dennis asks, is Datadog a good way to monitor Snowflake health and data pipelines? If no, what other tool would you recommend?
I have definitely seen Datadog in practice. Some teams do publish custom metrics to Datadogs for this sort of stuff. It works to a degree. It doesn't scale very great. Datadog has a terrifyingly steep custom metrics billing. So I would say if you're going, you can go that route. Just be careful how far you push it, because the bill will creep up on you. The other tools I would recommend, I mean, this is a tough one. Anything that is an observability tool that you can publish metrics into, or that can pull these metrics in and compute them, will do the trick. Hence why Datadog can work, Bigeye can work, anything that can do this sort of processing. If you really, really, really want to be lightweight, not have a tool, pull the data from Snowflake, pull the actual information from Snowflake. It's all available in their tables, and run some anomaly detection, some forecasting yourself. And I mean, like I said, a good 30-minute project would be pull the data from Snowflake, run profit on it, see what happens. Like it's a good experiment. And then once you reach the end of that, that's when you might want to start looking at tools.
Like Bigeye. So
like Bigeye,
yeah, exactly. So awesome. I know we're coming up on time. Thanks for being on the show. We'd love to have you back on sometime. We have a lot of fun chats. So it's cool.
A pleasure. This was a good conversation. Thanks for having me.
Yeah, anytime. For people who want to learn more about you or Bigeye, how would they do that?
You can find us at bigeye.com. You can also email me directly, Egor@bigeye.com. That's EGOR @bigeye.com. Or find me on LinkedIn, connect to me. I'm more than happy to answer messages on LinkedIn as well.
By the way, what does the name Bigeye mean?
So it's a little bit of a history lesson. So before Bigeye, we used to be called Toro Data Labs. And Toro the tuna, not Toro the bull. And then we rebranded into Bigeye, which is a type of tuna. So the pun stays.
I feel like naming is one of the hardest problems in startups, just as it is in software development.
We were talking with Jordan Tagani about this on Friday about Mother Duck, his new company.
There are two major problems in software engineering, right? It's naming, cache invalidation, and off by one errors.
Which is also the latter is also a major problem in math in general.
So. I think there's a joke in there too.
Yes, there is.
Caught that one. That's interesting. No, it's names are something I always get a kick out of. I've increasingly started wondering, like, how did you come up with this name? So Bigeye is one of the ones that's like, that's an interesting name. So
once we saw the logo, I think the team fell in love with the logo more, and they're like, oh yeah, this is actually really cool. And it's observability. It's like a lot of things kind of play into it. So it worked out really nicely.
Cool. I feel like it's almost a flex to just have a weird name. It's like saying, hey, we're so cool. We can use a name kind of like Google or Amazon that just, it's a weird name for our product. But someday people will all know this name. It'll be a household name.
Yeah, well, it's like Instacart. What was Instacart's name originally? Oh, jeez. It was something. It was like Honey Bear or something like that. Wait, do you guys know this one?
No, we don't.
Their original name was something also pretty strange, and then they rebranded to Instacart. Maple Bear, because they're Canadian. So
That's pretty funny. I was reading an article the other day about business names and how sort of the new wave of companies. I'd say new wave being since the 2000s and on. Back in the day, you used to have companies like International Business Machines or very descriptive, very serious sounding titles. Now it's it's Maple Bear and other companies. So it's cool. I like it. So awesome. Well, thanks to the audience for the great questions, comments. Let's see who's actually.
Thanks a lot.
So,
thanks a lot for everyone who dialed in and asked questions. That's what keeps these interesting, is questions from the audience.
Yeah, exactly. So next week we have Jesse Anderson. We're going to talk about some data team stuff. After that, we have Ethan Aaron on. After that, we got Laszlo Stranger. We got a whole cast of really fun characters. No Friday show this week. I'm actually going to be on going to be driving through the Midwest. So that's going to be very exciting. But anyway, we'll see you all next Monday. And thanks again, Egor.
Yep.
Talk to you soon, man.
Thank you.
All right. Thanks, guys.
Take care.